the number of sides.
Good. So it's 1/2, and I'm going to record this so that I can post on YouTube later. 1/2 times the S, which is how big each side is, times A, which is the apothem, times N, as in the number of sides. Okay?
Mm-hmm.
So in number 14, how big is one side of that triangle?
Oh, wait. I don't have it. For 14.
Yeah.
To like that one.
The side, yeah. How big is the side of the triangle?
Oh, 12.
12. So it's 12. What is the apothem in that one?
2 square root 3.
2 root 3, good. And how many sides does a triangle have?
3.
3. So we just type that in our calculator. And it should give us 62.4 ish.
Is 12 the total amount of sides, and then you divide it by 3, and then each side is 4, or 12?
12 is how long one side is.
Oh, okay.
2 root 3 is how long the apothem is. And 3 is how many sides there are. So there's 3 12s, essentially. So it's 3 times 12. Okay. So that's number 14. All right. Number 15 is different. So let's take care of that.
Answer 62.4.
Yeah, 62.4. That's correct.
Wait, but how do you get that?
Did you not type in your calculator?
Oh, no. Oh, okay. Okay, now I get it.
All right. So let's go to the next one, which is number 15. So number 15, it looks like it is a 1, 2, 3, 4, 5, 6, 7, 8, 9-sided shape. So let's go right here, n equals 9. So nonogon. Okay, now very carefully, Ben, are you looking at the question itself?
No, what page are we on? I was looking at that.
That's fine. That was page number 279, 729, I'm sorry, 729, today's homework. The homework that I gave out today.
I'm on it.
Okay, tell me about that side inside. Is that the apothem, number 10? That 10, I should say?
Yeah.
That's not the apothem.
No, that's the
I don't
radius.
even remember. I didn't study this that much.
Okay, so that's the radius. Good, Layla. That's the radius. So with that in mind, we have to find the apothem. So what we can redraw is a isosceles triangle.
That's why I kept getting it wrong.
Okay. So the side of the triangles here are 10. Because they're isosceles, you know this angle is the same as this angle.
Oh, so you 30/60 divided by 10 to find the angle, or that's something else?
That's for particularly. No, I don't know what you said. Okay, so I'm gonna cut this triangle in half. Okay.
Mm-hmm.
So this triangle in half will be the apothem of my shape. Okay, because it's like a bunch of little triangles on the side like that. Now, what is this bottom side, Layla? From the picture, you could tell what this whole bottom side is.
So confused. Like what 10 is, or what 6.84 is?
Yeah, so what's this bottom right here of the triangle?
Oh wait, I'm not on your drawing. No, I'm trying to go between like the textbook and here what you're drawing.
So I'm literally going to do it on the textbook then, okay?
Okay, thank you.
All right. So what I basically did is that I drew a little triangle like this, where this one's also 10. The radius is also 10. And then I cut it in half.
That's the thing with the A.
So it's 3.42.
Good. So then the half of the triangle. So I'm just going to redraw the triangle like this. So this is 10. This little half right here, this should feel familiar. This is like 3 tests ago. I don't remember, but where you have to cut it in half. So this is not 6.84. This is 3.42, that little piece right here, 3.42. Now, what theorem do we use to find a missing side of a right triangle? Search with a P.
Oh, Pythagorean
theorem.
theorem.
Good, both of you. Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. So a squared, I don't know what a squared is, plus b squared, which is 3.42 3.14 or 3.42 squared equals 10 squared. 10 squared is pretty easy. That's 100. Okay. So we're just going to subtract 3.42 squared on both sides. So let's see. Let me open up calculator. So 100 minus, and I'm going to put in parentheses, 3.42 times 3.42, close parentheses. So all of that, let me move this all over here. All of that, when I subtract it, is 88.3036. Okay? But that's not A. What do I have to do? That equals to A squared. So what do we have to do to both sides?
Square both sides. Or like unsquare it.
Yes, what do we call unsquaring though?
Dividing.
No.
I don't know. No,
Square-
wait. Oh, you just square root it.
Square rooted, good.
That's what I meant. My bad.
So we got A squared equals 86.3036. So we are going to square root it. On this question calculator, I think I could just click, where's the square root button? Square root, and then I'm just going to click answer. So it's going to refer to the last answer I had. Now I have 9 points, it rounds to 4, so 9.4. So my apothem, or my A in this case, 9.4.
Oh, so then you just plug that in.
Yeah, so let's plug that all into the equation. Okay, so let's plug that all into the equation. So we have 1/2. So what does the S stand for, Layla?
The side.
Good. So what is the side's size, I guess?
6.84.
Good. Don't use 3.42. So that could be a mistake because you changed it a little bit. Times the apothem, which we just found is 9.4. Times the number of sides, which is
Wait. No, 9.
9, I think. Yeah, it's a niner. Okay. So I have that all there. Let's see if I could go back to my calculator. It's a little hard to see from there. I gotta not use yellow.
Oh my God, what is?
There you go. It's on the top right here.
Yeah.
And then I'm just gonna try to type it in the calculator. So 0.5 times 6.84 times 9.4 times 9. And anyone who's watching this in the future, or anyone who did it by hand, your answer might be a little off with the decimals depending on how you round it. So it's okay if you're like, if you got like 288.3, that's fine, because it could be a little bit off depending how you round certain things. Okay.
Okay.
So that should be 289.33, it says to my calculator. They said 289.2 exactly. I got a little bit off. That's
Is the other one the same, like the way how you do it? Because then I could probably figure
It's slightly different. So let's do that, okay? So I'm going to erase all this. And then we'll go to the next one. I'll pick a nice color, red. There we go. Okay. Hey, Emma, we're just going over, nice background. We're going over 14 to 15 and 16, and I'm going to post this later on YouTube. So I'm going over 16 right now. Okay, so let's see. First, so we're looking for 3 variables, basically. How big each side is, the apothem, and the number of sides. So let's first look at here. The number of sides, we have 1, 2, 3, 4, 5, 6, 7. So we could put 7 for n. That's pretty good. The apothem. Which of these two are the apothem, Layla? 2.5 or 2.77?
Is this an optional Zoom?
Yes.
Yeah.
Oh, okay.
2.5.
2.5, good. So 2.5 is the apothem here.
Oh, we don't have the side.
Yeah, we don't have the side, so now we got to find it. What does this shape look like right here inside? The heptagon?
Like a triangle?
Yeah, what type of triangle though? A very particular triangle.
It has 3 sides. So
Every triangle has 3 sides. What type of triangle is this? It's a right triangle. Yeah.
A half triangle.
No, it's a right triangle. That's it. That's a right triangle. That's all. Now, what can we do with right triangles if we're looking for the side? What theorem?
Pythagorean theorem.
Good. So let's do the Pythagorean theorem. So 2.5 squared plus b squared. I don't know what b squared is. It doesn't matter which one you call a and b, by the way, just a reminder. 2.77 squared. Okay. So I do all of that, but then I'm just going to go to my calculator and do it.
Wait, then this number is going to tell us.
This is going to tell us the half of the side.
Oh, and then you could double it.
Yeah, I need double it. So 2.77. I don't know how do you do a square here, so I'm just going to do 2.77 again. And we're going to subtract it from the 2.5 squared. So subtracted by 2.5 times 2.5. So we got b squared equals 1.4229.
Wait, what was the c squared?
2.77. It was the radius of the shape, but you could tell it's the hypotenuse because it's the one that's across the right angle.
Got it.
So that's b squared equals 1.4299. But then we square root both sides to get the actual b. So we're going to do square root the answer. So it looks like it's going to be 1.19. So b equals 1.19. Now let's go back here to the picture. So 1.19 is half of it. Leila, you already said what we have to do. What do we have to do to both of them?
You double it.
Good. So we're going to double that. That should be 2.
Like 38.
Good. Thank you. 38. So we found our side, 2.38. Now we could actually plug it in the calculator, or the function. So 1/2 times my s, which I just found was 2.38, times my apothem, 2.5, times my number of sides, which is 7. Let's go to the calculator and do all that. Let me just move this down here. So 0.5 times 2.38 times 2.5 times 7. So we got 28.825, that rounds to 28.3. Yeah, that makes sense. 20.9, and we got, and we got 20.8. Yeah. So again, a little off the rounding, but that's fine.
Okay, thank you so much.
Hey, no problem. All right, Ben, you want to help with other questions? You're muted.
Sorry, I'm just confused with like this entire like thing. So
This section in general or the last section?
This section.
Okay. So I'll do a little explaining, okay?
Yeah, cool.
All right. So let me just pull out a whiteboard then so I have some space. So every regular polygon could be drawn like this. So every regular polygon, so I'm going to draw, let's say, a regular, let's see, a pentagon, let's say. I end up drawing a hexagon, whatever. Okay, so every regular shape, every regular polygon. Now, just to ask, to make sure, what does a regular polygon mean? What does it mean to be a regular polygon?
It has all its sides and angles are equal.
Good. So every regular polygon can be what we call circumscribed, which is a circle is drawn completely around it. And again, because I'm doing this by mouse, it's not going to look good at all. But
yeah, I know what you're saying.
Yeah. So because of that, we could tell a couple of things from that information. Okay.
Yeah.
All right. So first off, we could tell that because the corner also hits the circle, and there's a center to the regular polygon, the distance from the center to a corner of a regular polygon is the radius. And we call that the radius of the polygon.
Okay.
Now, if we had two radii like this, and imagine this is touching the circle. So this is a radius and this is a radius. We'll have some angle here, some theta, okay?
Mm-hmm.
Now, we could figure out that angle with this information. We know every circle in total is 360 degrees. That's a fact, okay?
Okay.
I feel like anyone would know. Now, because this has 6 sides, this is a hexagon in this case, because this has 6 sides, I know this little piece is going to be 1/6 of the circle. So I could just divide it by 6.
Wait, the radius is gonna be 1/6?
No, the angle, the theta is going to be 1/6.
Oh, okay.
You can make 6 pizza slices if you want to think of it like that.
Okay.
Yeah, so that's 1, 2, 3, 4, 5, 6. So there's 6 pizza slices. So this pizza slice right here is going to be 60 degrees. Okay?
Mm-hmm.
So that right here is the internal angle or interior angle, we might call it. Okay?
Yeah.
So what if I ask for how big is it from here to here? So the blue.
120 degrees.
Good, yeah. You just take whatever your minor angle is and then multiply it by how many arcs or slices you're taking. So it's 2 slices, so you double it. If it was 4 slices, you quadruple it, you know?
Yeah, that makes sense.
So there's another thing we could tell from this, though. These right here, these red triangles, these are radii, form isosceles triangles, isosceles triangles. So
Mhm.
this angle here is equal because the radiuses are equal, right? So
Yeah.
that, remember, from the opposite sides are equal, then the opposite angles are equal. That's from chapter 7, I believe, a while back.
Yeah.
So since we know these are isosceles triangles, we could cut this in half and make a perpendicular bisector. So all these old triangle stuff is still coming back around. So we made this a perpendicular bisector. Okay, so what does a perpendicular bisector help me with? Well, now this is a right triangle. If I have the radius and let's say a side, I could find this missing piece. And we're going to call this missing piece the apothegm. So if I have the apothegm and the side, I could find the radius. If I have the apothegm and the radius, I could find the side. And from 15 to 16, that's what we basically did. We used one of the things we had to find the missing thing.
Okay.
Okay? So there's this formula. So each area, now what's the area of a triangle? You remember what that is? 1/2.
180.
That's the how many the angle add up to. I just want to ask you, what's the
Oh,
area of a triangle?
Oh shoot, I think I forgot.
BH. What does B and H stand for?
Oh, base and height.
Good. So this is base and height.
Oh,
Now
I
let's
should
look
know that's my initials.
there you go. Now let's look at here. This side right here happens to be the base of a isosceles triangle. And this line over here happens to be the height. So this right here, let's pick a different color. This right here, base, could be rewritten as the variable s for how the size of the size is. The size of the side. So how big the side is. And the height can be changed into a different variable, the apothegm, because the apothegm happens to be the height of this right triangle. The 1/2 is still there. So the 1/2 is still there. Now, that tells me just the area of this triangle here. So Ben, what would you do to find all the areas?
Multiply
By
6.
6. Or in this case, we could say multiply by how many sides there are. So we're going to multiply by how many sides there are, and we represent the number of sides with n. So 1/2 a san. So what does that mean? This equation right here is to find the area of a regular polygon, okay?
Yeah.
And then number 14, they give us the apothegm and the side, so we could just plug it in. 15 and 16 are those like second level questions where you have to find one of the missing variables before you can find the area.
Okay. Got it.
All right, feel a lot better about it?
Yes, I do. Thank you.
All right, no problem, man.
All right. Have a good rest of your day.
Hey, you too, man.